23 from section 6.6. Let's rewrite the problem up here. 4 plus 5 to some power equals 15. Okay, the first thing I'm going to do in any of these problems where I'm trying to solve for the exponent is try to isolate the base and the exponent on one side. What I mean by that is anything else on that side of the equation needs to be removed before we can use logs to solve. So I'm going to take away this 4 from both sides. So it's going to be 5 to the 6 minus x equals 11. At this point, when I have base to a power equals a number, I think logs. Logs came about so we can solve for the missing exponent, 6 minus x. So the log of 11 base 5 equals 6 minus x. Over here should be able to be done on a calculator. So we need to do the log of 11 base 5. So math, alpha, math, base 5, 11, enter. I typically like you to round these to the nearest thousandth. So that would be 1.490 if you were rounding to the nearest thousandth. So 1.490. 1.490 equals 6 minus x. Now, if I'm solving for x, I would probably add the x over to the left and then subtract the 1.49 over to the right. Okay? If you wanted to subtract 1.49 and then do it that way, you could, but I'd rather have my x come over to the left and become positive, and then on the right, do 6 minus 1.49 to get x. So is that 4.51? 4.51 should be the answer. Don't forget, in pretty much every math problem that exists in the world, you can take your answer and plug it in for, you can take your answer and plug it in for x to make sure it gives you a pretty close solution. All right, so on my calculator, if I try 4 plus 5 to the 6 minus that, I should get something close to 15. 4 plus 5 to the 6 minus 4.51 should be pretty close to 15. It looks like a good answer. It's not exact because when we did the log, we rounded it. That's number 23. Let's see.